Hello dear students, welcome to the Royal Palace PU College online classes. So in today's session I am going to discuss about the one of the three most important questions, that is preparation of H2SO4, that is sulfuric acid by contact process. So here this manufacture or preparation of sulfuric acid by contact process mainly involves what here, 4 steps. So especially the first step, that is production of SO2. Okay, so here the sulfur on burning, so or sulfide ores on burning in air, so that produce what here, sulfur dioxide. Here the sulfur on burning with what here, air, so there is a formation of what here, sulfur dioxide. So this is the first step, production of sulfur dioxide. So the sulfur dioxide which is formed by the burning of what here, sulfur in air or sulfide ores. Here I have written 2 reactions, and this is an sulfide ore and this is just sulfur burning on burning in air. So there is a formation of sulfur dioxide. This is first step. So similarly I have written here the burning of sulfur and or sulfide ores in air. So here the first thing, the burning of sulfur in air, so there is a formation of what here, sulfur dioxide. And this one, sulfide ores on burning with air, so that is formation of what here, again here, sulfur dioxide. This is the first step. Just you have to remember that one, the first step, that is production of sulfur dioxide just by burning of sulfur, that is S plus O2, that gives what here, SO2. Okay. So the next one, the oxidation of SO2. So whatever the sulfur dioxide produced in first step, so that will undergo again oxidation. So there is a formation of what here, sulfur trioxide, sulfur trioxide. This is a second second step, production of sulfur dioxide converted to sulfur trioxide. Sulfur dioxide undergo oxidation, formation of what is sulfur trioxide. This is a second step. Okay. So here the second step, that is oxidation of SO2. So again the SO2 undergo oxidation, that is addition of oxygen in presence of vanadium pentoxide catalyst. So what happened, the sulfur dioxide that will oxidize to sulfur trioxide. So this is an second step, that is oxidation of SO2. So SO2 undergo oxidation in presence of vanadium pentoxide catalyst and 720 Kelvin temperature. So there is a formation of what here, SO3. That means the first step, the production of SO2 simply by burning the sulfur in air. So that S plus O2, that gives what here, SO2. And in second step, whatever the formed SO2 is there, sulfur dioxide, so that will undergo oxidation in presence of vanadium pentoxide catalyst and temperature 720 Kelvin temperature, and there is a SO2 is oxidized to what here, SO3. Okay. So this is an second step. So the next one, that is the whatever the SO3 that gas produced, that is absorbed in the H2SO4 to give H2S2O7. So that is H2S2O7, it is called what here, oleum. Okay. Now the third step is, that means the SO3 gas, so when it is absorbed in H2SO4, so there is a formation of what here, oleum, that is H2S2O7. Okay. So after this whatever the dilution of oleum, so in presence of water can be takes place, so there is a formation of what here, H2SO4. So these are the 4 method of the preparation of H2SO4 by contact process. Now continue part of the again this one, preparation of H2SO4 by contact process involves 4 steps. So one is production of SO2, and second one is oxidation of SO2, and the third one is SO3. So that is SO3, that will formation of SO3, oxidation of SO2 can be takes place, and formation of SO3. Okay. And the third step, that is SO3 gas absorbed in H2SO4 to give H2S2O7. So this is an oleum. So whatever the SO3 form that is combined with H2SO4, so just H2SO4 plus SO3, that will become what here, H2S2O7. So this is an oleum, and this oleum diluted with water, so there is a formation of what here, H2SO4. So this is an very important question for your board examination. Preparation of sulfuric acid by contact process. It is very simple. The first production of SO2. The SO2 is formed by the burning of sulfur or sulfide ores in presence of air. So I have given one reaction S plus O2, that gives what here, SO2. So the second step is what here, the SO2 to SO3. That means SO2 undergo oxidation. There is a formation of what here, SO3 sulfur trioxide. So just by oxidation, the SO2 undergo oxidation in presence of vanadium pentoxide and 720 Kelvin temperature, and there is a SO2 that will undergo oxidation, formation of what here, SO3, that is sulfur trioxide. And the third step, SO3 gas absorbed H2SO4, there is a formation of what here, oleum, H2S2O7. Okay, so SO3 plus H2SO4, that gives what here, H2S2O7. So this is an oleum, and later on this oleum, which is diluted with what here, water. So again here H2S2O7. So this is an oleum. So when it is diluted with water, H2O, so there is a formation of what here, H2SO4, sulfuric acid. So this is about what here, preparation of H2SO4 by contact process. Now here the next concept, that is sulfur allotropic forms. Okay, so mainly here two types of allotropic forms are there, sulfurs, that is a rhombic sulfur, another one is what here, monoclinic sulfur. So the rhombic sulfur, it is also called what here, alpha sulfur, and the monoclinic sulfur, it is also called what here, beta sulfur. And the melting point of this rhombic sulfur is 385.8 Kelvin, and these are formed by the dissolving what here, this rhombic sulfur in carbon disulfide. Okay, it is rhombic sulfur, it is soluble in carbon disulfide solvent, whereas it is solubility is less in alcohol, ether. Okay, in water the solubility is less, rhombic sulfur, but it is soluble more in what here, carbon disulfide. And the rhombic sulfur, which is formed by the just dissolving what here, rhombic sulfur in carbon disulfide, it solubility is minimum in water, alcohol, ether, and their melting point, as I told here, 385.8 Kelvin. Okay, and the rhombic sulfur, which is yellow in color, and this is about what here, allotropic form of sulfur, that is alpha sulfur, that is rhombic sulfur. Okay, the next one allotropic form of sulfur, that is monoclinic sulfur, and this is an beta sulfur. This is also called beta sulfur, and melting point is 393 Kelvin, and it is also same, soluble in carbon disulfide, because here both alpha sulfur and beta sulfur, these are soluble in carbon disulfide. This is a good solvent, universal solvent, this one, carbon disulfide, and it is prepared by the melting of this sulfur only. So after melting of rhombic sulfur, we will get what here, monoclinic sulfur, that is beta sulfur, and which is cooled above what here, 369 Kelvin. Here one important definition is there. So transition temperature regarding these two allotropic forms only. Now beta sulfur, which is stable above what here, 369 Kelvin temperature only. Okay, so the beta sulfur, which is, I mean monoclinic sulfur, which is stable above 369 Kelvin temperature, and when the temperature decreases below this one, 369 Kelvin, so the beta sulfur converted to what here, alpha sulfur. See, 369 temperature, I mean 369 Kelvin above temperature, beta sulfur is stable. When the temperature decreases below 369 Kelvin, the beta sulfur is converted into what here, alpha sulfur. Okay, so here this is one point, and one more point is there, alpha sulfur, it is more stable below 369 Kelvin temperature. Okay, so beta sulfur, so I will write here, beta sulfur stable above 369 temperature, beta sulfur, I will write beta sulfur, whereas below 369 Kelvin temperature, alpha sulfur is stable. Okay, so this temperature is called, 369 Kelvin temperature is called transition temperature, because particularly at 369 Kelvin temperature, these two forms, beta sulfur and alpha sulfur, they are this stable. So when the temperature varies, for example, when the temperature below 369, so what happen, when the temperature decreases below 369, the beta sulfur is converted into what here, alpha sulfur. So whereas when the temperature increases above 369, the alpha sulfur is converted into beta sulfur. So this temperature, that is 369 temperature, at particular 369 Kelvin temperature, both forms are stable. So that temperature is called what here, transition temperature. Transition temperature. So here these are the structure of what here, S8 molecule in rhombic sulfur, and this is an S6 molecule. So these are the S6 molecule structure, and this is an S8 molecule structure in rhombic sulfur, and this is boat form and this one is chair form. So in boat form we have an bond length that is 204 picometer and bond angle is 107 degrees Celsius. So whereas in chair form the bond length is 205.7 picometer and the bond angle is 202.2 degree. So this is about what is structure of S8 molecule and S6 molecule. Okay, so now the next one, that is preparation of sulfur dioxide. So the sulfur dioxide, which is prepared by the sodium sulfite, react with what here, dilute sulfuric acid, and there is a formation of what here, sulfur dioxide and sodium sulfate. So this is an preparation of sulfur dioxide. So the sodium sulfite Na2SO3 react with dilute sulfuric acid H2SO4, that gives what here, sodium sulfate Na2SO4 plus H2O, and here production of what here, SO2, sulfur dioxide. And sulfur dioxide, which is also prepared by industrially, that is roasting of sulfide ores. So this FeS2, it is an sulfide ore by roasting. Roasting means heating of ores in presence of air, excess of air. So here the roasting of sulfide ores in presence of air, excess of air. So there is a formation of what here, sulfur dioxide. So this is another one industrial method for the preparation of what here, sulfur dioxide. Okay. The physical properties, the sulfur dioxide, it is colorless gas with pungent smell, and it is highly soluble in water. It is highly soluble in water. It is a colorless gas with having pungent smell, and it is readily soluble. It is highly soluble in the water. So these are the physical properties of the sulfur dioxide. So sulfur dioxide, which is prepared by the sodium sulfite, react with the dilute H2SO4. There is a formation of sodium sulfate, water and sulfur dioxide. This is first one method. And second one, industrially the sulfur dioxide, which is prepared by the roasting of sulfide ores. So roasting means, as I told, the heating of ore in presence of excess of air. So that is called what here, roasting. So here sulfide ore react with the, roasting in presence of air. So that gives what here, sulfur dioxide. This is another one method. And the physical properties, as I told, these are the colorless gas having pungent smell, and it is highly soluble in the water. So this is about what here, physical properties of sulfur dioxide. So now the next one concept, that is chemical properties. Chemical properties, the first one, that is acidic properties. So we know that the sulfur dioxide react with what here, water. Sulfur dioxide react with water. So here there is a formation of sulfurous acid, H2SO3. So H2, S is one is there, H2SO3. Hence this is a sulfurous acid. Sulfuric acid means H2SO4. But here when the sulfur dioxide react with water, there is a formation of what here, sulfurous acid. Now the second one, when they react with sodium hydroxide. So okay, sulfur dioxide, when they react with what here, sulfur dioxide. So sulfur dioxide react with sodium hydroxide, there is a formation of what here, sodium sulfite. This is Na2SO3. Na2SO4 means sodium sulfate, and here Na2SO3 is there, sodium sulfite is formed, and this sodium sulfite again, that is react with more sulfur dioxide, there is a formation of what here, sodium hydrogen sulfite, NaHSO3. Now the same thing, the sulfur dioxide react with NaOH, there is a formation of what here, sodium sulfite. Okay, that sodium sulfite react with more SO2, sulfur dioxide, there is a formation of what here, sodium hydrogen sulfite, sodium hydrogen sulfite. And next one, that is addition reaction. The sulfur dioxide react with chlorine in presence of charcoal, that is what here, sulfuryl chloride, SO2 Cl2. So this is another one addition reaction. Sulfur dioxide react with chlorine in presence of charcoal. Charcoal, it is a catalyst, and there is a formation of what is sulfuryl chloride. And here one more thing, the sulfur dioxide that will undergo oxidation. So already this reaction we know that one, the sulfur dioxide undergo oxidation in presence of vanadium pentoxide catalyst, and that gives what here, sulfur trioxide. This is an addition reaction. So in next class we will continue about what here, some more examples, I mean some more reactions about what here, sulfur dioxide, that is reducing properties and allotropic form of sulfur. So we will study in next class. Thank you.